And so dx dt ends up being 20 minus 6 or 14. So dx dt is minus 8 over 14 minus 4 over 7.
Okay.
Is that kind of okay so far?
Yeah, but do you have any of like the word problem ones? Because we do a
Yeah,
lot
we're
of.
gonna get to those. These
Okay.
these build into that. You have to
Yeah.
be understanding that every variable is with respect to time. These
Okay.
are just the starter problems.
Okay.
Um, yes, there's a million word problems you can do. Don't worry about that. So the kind of the starter ones here are, and we'll just grab one here. Does your instructor give you formulas for like area and volume and stuff like that, or do you think you're gonna have to know them on your own?
He should give them to us.
Okay.
I'm pretty sure.
All right. So you have to recognize that in this problem, A and R are the variables. So when you
Mm-hmm.
take your derivatives with respect to A, it's dA dt, and with R, it's dr dt. Could you differentiate this thing for us, please?
Yeah. Okay, so dA dt equals 2 pi r dr dt.
Okay. So now you got to figure out what you're finding. It's dA dt. They give you R, they give you dr dt, so you have to do this exactly.
Okay. 12 pi? Oh,
Yeah.
yeah.
Now we're gonna start getting into units. And units are really important here, but for these problems, not so much. So here's kind of a more complicated one. Just see how you do on something like this. You have to be able to take a derivative of
We
both
just use
sides.
quotient rule, right? For
I would
the,
not use quotient rule here. It looks like quotient rule, but because there's one term on the bottom, you can divide both of them by h. And this is probably your
okay.
better path here as your rewrite. I think that's why it's here. It's to look like quotient rule, and it's really not. Let me know what you come up with for your derivative on this.
Okay. So 1/4 dr dt equals 3h negative 2 dh dt.
Didn't hear it, but there's a negative that you need.
Oh, I did not get the negative, but I see
Yeah.
that.
All right.
Wait,
So you got to
if
make sure
it's
you always know. What?
if you're multiplying negative
Oh
one,
yeah.
then
All right.
negative two.
Yeah, you're right. It is
Okay.
positive. It's positive. So make sure you know what you're solving for. It's easy to like not know. Um,
Okay.
and depending on your comfort level, you can like write it out symbolically. Like you're gonna multiply both sides by h squared and divide by 3. So it ends up being h squared over 12 dr dt. Then you're just putting those numbers in.
Okay. Wait, how'd you get h squared over 12?
You're what did you get, I guess, when you solve for
So,
DHDT?
I was working on it. I just did the 1/4 times one
You,
fourth, and then equals 3, 2. Um, wait, actually, can you walk me through that?
Sure, sure. That's part of what I'm doing here. So I would rewrite it if you're not super comfortable with what I just did. So it's 3 over h squared times dh dt. You just multiply by the reciprocal, which is h squared over 3. You never want to divide a fraction by a number. It's better to multiply by the reciprocal, 1/3.
Yeah.
So that's why it becomes h squared over 12 on the left here. H squared over 12 dr dt equals dh dt like that.
Okay, that makes sense.
All right. So then you got to put the numbers in. Go back to the original. H H was given as 12. The RDT was given as 1/4.
Wait, so 12. Um, 3? Oh, yeah. Okay.
Yes. Yep. Good. Okay, let's do one more of these kind where they're a little more challenging and then we'll move to the word problems here.
Okay.
All right, so see if you can work this all the way through.
So how do I do that if I don't have the value of b?
So you have to use the original values. 10 squared
Oh,
equals 8 squared plus b squared. Good question, because that's going to come up in some future problems.
equals 8 squared equals b squared. Okay. So, okay, I got dc dt equals 1/2.
Okay, so your derivative is 2c dc dt
Yes.
equals 2a dA dt plus
Mm.
2b dB dt. And since they're all divisible by 2, I would get rid of that 2.
Yeah, that's what I did.
Simplifying if you can. Good. And you gotta make sure you know what you're solving for, which is dc dt. So I would actually multiply everything by 1 over c. That's kind of the cleaner look. So it becomes A over C times dA dt plus B over C times dB dt. And like you mentioned, you have to find B. B is 6. And so you just put the numbers in that you have 8 over 6 times dA dt, which is 1/4, plus 6 over 10. I got the wrong number here. C is 10.
Yeah.
C is 10 times 1/2. All right, so you got 2 over 10 plus 3 over 10, which is 5 over 10, which is 1/2. Very good. All right, on to the actual problems that you will see in a real class, I guess. Okay, so there's a couple of like classic problems that they give you. Uh, One is some sort of a distance, rate, time problem. Trying to see which one. One's a ladder problem. Let's do the ladder problem first. It's more like the one we just did. You probably saw these. Like they don't get too creative when they get to testing, for the most part.
Yeah.
All right. So a ladder is leaning against the side of a house. So you have to draw the geometric. Whoa, that's not very good. Something roughly. This is 13 feet, and it says it's sliding away. So I like to use arrows to show rates.
Okay.
If it's sliding away, that's dx dt. Down is dy dt. You probably saw that. And then the base is moving at 4, and it's 12 feet from the house. And that's everything we know. Is that okay so far?
Yes.
So what is the
Pythagorean theorem.
yeah, what is the equation here? So it's
Uh,
kind of like an x squared plus y squared equals b squared.
yeah.
Now the ladder is fixed. That's one of the important differences from what we just did. Like even though it's a variable, it's not changing. Like its length stays the same. So when you take your derivative, 2x dx dt, 2y dy dt, because it's a constant, the derivative is 0.
Okay.
And if you don't remember to do that and then you write dd dt, that's 0 as well. Like its rate isn't changing. So the whole thing is 0.
Okay.
Right. So we're looking for dy dt. So will you attempt to solve that for us, please? For dy
Yes.
dt.
Okay, I got 43, but that doesn't sound right at all.
So it's got to be negative. That's
No,
kind of
I
the
got
first thing. It's
negative
going to.
43.
It does seem really big, really large. Okay, so
So,
let's take a look here. So this whole right side is 0. This was my point, and I don't know if I made that clear or not, but the whole right side is 0. Is that what you had, or did you?
yeah, I had the whole right side
Okay.
zero.
So dy dt, when you solve for dy dt, you have minus 2x dx dt, and then you divide everything by 2y. So your dy dt is minus x over y times dx dt. Do you have something like that?
No.
Okay, that's where your issue is. And
I
then you
just
don't
did
have the y. Go ahead.
I did 2x or and I canceled so I did 2x dx dt plus 2y dy dt and I canceled out the 2's.
Yeah, they
And
cancel,
so
but
then I
you
had
gotta, yeah. So
x dx
x
dt
dx dt
plus
plus
y
y
dy
dy.
equals 0. And then I just moved everything over at the end.
Okay, that's you still get the same thing. You still should get minus x over y dx dt.
Okay.
So take a look at that, or I mean, all you're doing is subtracting x dx dt from both sides
Yeah.
and then dividing by y.
I used I did a squared plus 12 squared equals 13 squared to find the value of y.
Yeah, y is should be 5.
Yeah.
Right. So dy dt, do you agree though? This is where before you even get those values in, you have to agree that this is the dy dt. It's minus x
Yeah.
over y dx dt.
Yes.
Okay. And then you're right, y is 5. So it should be minus 12 over 5 times 4. I think dx dt is 4.
Yes. So negative 9.5.
Sure. It's okay to leave it as a fraction. Now, the first problem we're going to talk about units. Units are just as important as your final answer. So it's a rate, which means it's per unit time. You want to use the same consistent rate. So it's really 4 feet per second. So your answer is also feet per second.
Okay.
Minus 48 over 5 feet per second. Is that okay?
Yes.
Okay. Now they typically ask you for one or the other. They ask you for the rates sliding down or sliding out. But then this part B is the second type of question that you could get. And they want the rate of change of the area of the triangle. So you have to be able to write the formula for the equation of area. So the area of a triangle, as you know, is 1/2 base times height. The base is x and the height is y.
Okay.
So you have to be able to take a derivative of this dA dt, but this time it's product rule. X, Y, product rule and related rates. So it's keep the first, take the derivative of the second, dy dt, plus the derivative of the first, dx dt, times the second. So now you need the x, the y, the y dt, and the dx dt.
That's fine. Okay. And we're using the same values as before, right?
Yes.
Okay.
So I think we said 12 dy dt was minus 48 over 5 plus 4 times 5, and you're going to take a half of all that. This time, though, the area, the units of area are squared, feet squared per second.
Okay. So negative. Wait, why do I get a negative number for area?
because it's the
Oh, it's
area is
because
decreasing. It's
okay.
okay that it's the rate of the area, not the actual area.
Wait, I got for negative 47.6.
That's just a calculate. I mean, I don't know. Could be a calculator. I mean, I didn't really check these numbers. It might be right. Let me check. So the actual number is not as important as just the flow of this.
Yeah.
That's really like you have to be comfortable with writing the equation, taking derivatives, solving for whichever rate you're looking for, things like that. Let me check here. I just hadn't made much of an effort to calculate it. Yeah, that's right.
Oh, okay.
And I'll check if there is a solution to this thing I pulled. Yeah, we got it. That's all correct.
Okay.
I mean, 4 feet per second is pretty fast for a ladder to be moving.
Yeah.
Uh, like you don't even you don't even walk 4 feet per second. I don't walk 4 feet per second. That's pretty fast, unless you're running maybe. But um, all right. So that's kind of a triangle problem, and then there's always potentially, and this is a good one because we haven't done this yet. It's got two variables. Is the cone conical? Some sort of a cone problem here. So water runs into a conical tank at the rate of 9 feet cubed per minute. So sometimes students say, well, how do I know what it is? You use the units. So the units of feet cubed are volume, dV dt. All right.
Okay.
If you're ever unsure, try to match up the units there. All right. So what's the volume of a cone? I guess you're going to be given it's 1/3 pi r squared 8.
And we just find the
And
derivative, right?
well, this poses a we're gonna take the root of this. It's dv dt, and we're gonna see the issue here. 1/3 pi, and then it's product rule between r squared and h. So it's 2r the r dt 8 plus r squared dh dt. Let me know if you agree or if you have any questions about that.
I got that.
Okay, now one of the problems here is that they're asking for dh dt, water level rising. You have to find dH/dt, but you don't know dR/dt, and there's no way to calculate it, which means that you cannot do this problem as is. And you might be wondering, well, how do I do this problem, of course? So there's this classic, like, yeah, you have to know something to be able to do it. There's there's two triangles. There's kind of like the big triangle and the little triangle. So the big triangle is the height, and and then this is the radius 5, 10, and 5. So that's the height of the cone and the radius. Is that okay?
Yes.
And it's really H and R in our problem. So you set up a proportion where you'd say something like H over 10 equals R over 5,
Okay.
or it could be the other way around. But now it's like, well, which variable do I solve for? Well, because we want to solve for we want to solve for dH/dt, we need to get rid of the r squared. So you have to solve for r. It's not necessarily clear which variable to solve for until you think ahead about which one you actually need. So we're not actually going to use this equation right here. We're going to solve for r in the proportion, which it ends up being 5h over 10 or h over 2.
Oh, we're cross multiplying, right?
Yes. Yes. And then that's going to go in for r. So your volume is really 1/3 pi instead of r h. over 2 squared times h. So it becomes pi over 12 h cubed. And this is a very, very common approach, which is to draw a triangle, use similar triangles. Is that okay so far?
Wait, how'd you get the pi 12? Oh, wait, you just,
Yeah,
never mind.
2 squared is 4 times 3.
Okay, that makes sense. And then we find the derivative of that equation.
Yes, exactly. And
Okay.
it's in one variable, so it's not, there's no no product rule. 3 pi over 12 h squared dh dt. It's a lot nicer now to deal with. So you've got dv dt equals pi h squared over 4, and then you can solve for dht. So you do that by multiplying by the reciprocal.
Oh, oh, that makes so much sense. So,
And then you've got dv dt that was given in the problem. The dv dt ended up being 9. And then h was given as 10. I'm sorry, 6. Sorry, 6. So if you look back in the original problem, I didn't just scroll up for that. Yes, the height of the cone is 10, but you only care when it's 6 feet deep. So you have to be
okay,
sure that you know which one you're using. So it's 4 over pi 6 squared times 9 ends up being 1 over pi, believe it or not. And then units, dh dt, height is in feet per second. Maybe, you know, put a box around units, the top of your test to make sure you check for those at the end.
okay. That makes. We did a problem like that in class, and I had no idea how to do it, but that makes so much more sense.
Okay, great. The similar problem to this is the one with it's a man walking or woman walking away from a light. Have you seen that one in
I
class?
did not see that one actually.
All right, so we should work on this one. All right. So a light is on. Okay, so sometimes the light is on the ground. This one's actually different. Usually the light is in the air. Let me let me choose a different problem because this is not the one they typically use. So if you're okay with that, weird that the light's on the ground. That's really weird. Um, all right, sorry about that.
That works.
All right. It's always a man, I mean, I just, I mean, it's like men, we're still, we're walking towards these lights. I don't understand. But a person 6 feet tall walks at the rate of 5 feet per second towards a street light that is 16 feet above the ground. At what rate is the tip of his shadow moving? So it takes a little bit of like, I mean, I don't walk out in the very often, but they like there's a certain setup to these problems that you want to do. Like there's just that governs these sort of things. So there's the man. Man is 6 feet tall, and the light is there. And for whatever reason, they call this they like, and it's like there's a certain way that they like to label these things. Um, you can use whatever, but this we'll call this the length of shadow of the man. Like the man has a shadow of some length. And so does, so does, and there's also this length here, which is called x. Okay, so it's really two triangles again. It's the 6 and the y and the 16 and the x.
Okay.
All right, and then the man is walking toward the streetlights, so dx dt here, dx dt, it ends up being negative. The reason it's negative is because we generally think to the right is positive.
Yeah.
So left is considered negative here. So the so what's going on here? So you set up a proportion like we did before. 6 over y equals 16 over x, and then you solve for either x or y. Okay.
Okay.
Now that's kind of the rough part of it. A lot of problems they end up making this z, which I don't like, but this is kind of the traditional way to work these out. And so they end up that's why I don't like these problems. They're very complicated. Um, so you set up this proportion on the right, and if you solve it for x, or I'm sorry, if you just cross multiply like we were talking about, you can you can solve you can take a derivative of both sides.
6 and 16.
Yeah, it's 6 dx dt, 16 dy dt. And what we're looking for is, let me go back and look, tip of his shadow moving. The length of his shadow is dy dt. So his shadow is this y, but he's moving in this direction dx dt. So it's a little wonky, but the answer here is that the x dt, no, sorry, dy dt. Why isn't this working out?
Can we just plug in -5 for dx dt and then
Yes,
divide that by 16?
yes,
Okay.
yes. So yeah. So you're generally solving for dy dt, which is 6 over 16 dx dt, which is 3 over 8 times minus 5 is dy dt. And there you go. Um, I would ask your instructor to do the light problem in class, see if you can get a feel if you're going to need to do it. It's for whatever reason the more complicated triangle problem that you might
Yeah.
get.
Okay.
All right. So we're covering kind of all the possibilities. So the next one that tends to be given is like a spherical balloon or a cone or some sort of spherical thing.
Yeah, I've seen some of those.
There's also cars moving away, but we can do a spherical problem, but
Okay.
it's only in one variable, so it's not as awkward as the previous one. But like this is your question here. It'll say spherical balloon is inflated with helium at a rate of 100 pi feet per minute, and that's volumes. That's dV dt. Very occasionally they give you like minutes and seconds. They'll kind of mix that up. Just be on the lookout for that.
Okay.
So why don't you try this one on your own? You can ask me some questions if you need to. I'll try to look and see what else. Uh, there's sometimes one with, oh, we've got to do some other tangent line stuff anyway. So we'll make this the last one before we do some tangent line stuff.
So I'm getting 100 pi divided by 100 pi equals dr dt.
That's possible. So that would just be, that would cancel out, be one.
So dr dt would equal 1.
And what are the units though of that, of the radius?
Um, feet per minute.
Yes.
Oh, that could totally make sense.
I mean, how do you know if any of this is reasonable? I mean, until you know,
Yeah,
right? Like none of them, you just got to be, go with it, make sure you're okay with your numbers.
yeah,
Because you're right, this is 100 pi equals 4 pi 5 squared dr dt. So dr dt equals 100 pi over 100 pi, which is 1 feet per minute, 1 foot per minute. All right. The next question that they ask here is about surface area. So sometimes they throw that in. Um, and you may wonder, well, why are we even doing this? It's because you sometimes have to use the result from part A. So in this case, A is 4 pi r squared. So when you take a derivative on the right, you need dr dt. That's why you have it from this line here.
yeah. And then we just plug it in.
Yes. Okay.
Oh,
All right. So let's do some tangent line problems.
okay.
All right. So let's do sine y plus x equals I got to make this reasonable here. Um, Sorry, I'm stalling. I'm trying to pick a nice value here. Uh, equals 1. And let's say that x equals 1/2.
Okay. Okay. Mm. So actually, like, I don't know how to do this.
Say that one more time.
I don't know how to do this, like, at
Okay.
all.
So the first thing here is like you can take a derivative. So it'd be sine, derivative sine is cosine y dy dx plus 1 equals 0. Is that part okay?
Yes.
Okay. And then you solve for dy dx. And so that's -1 over cosine y. But what is y? Well, we weren't given a y. Do you agree with that? There's no y.
Yes.
So how do we find y? Well, we have to use this x back in the original equation. Just like with those triangle problems, you have to say, okay, it's really sine y plus 1/2 equals 1. Sine y equals 1/2. Well, what's the y value when sine is to get 1/2? It's like how comfortable are you in a unit circle? That's pi over 6.
Okay.
Pi over 6. Okay, so y is really pi over 6.
Okay.
Okay, so now you need -1 over cosine pi over 6. Do you remember that?
It should be square root of 3 over 2, I think.
Yes, yes. So when it's -1 over square root of 3 over 2, which becomes -2 over the square root of 3. Then you have to rationalize. This is all review. That is your slope. Like you're doing all that because that is your slope.
Okay.
So you get your slope. And your equation of the tangent line is y minus y1 equals mx minus x1. So that's your slope. You also needed an x1 and a y1, which is why we got the x
One.
is 1/2, y is pi over 6.
Okay.
And if this looks really awkward and weird, like To me, this is medium difficulty. Maybe I'm not, maybe I'm being too extreme.
No, this is good.
But this is, I mean, this isn't terrible. Um, all right. How about let's say y equals natural log absolute value secant x, and we're gonna do this when x equals 0. X equals 0. So go ahead and take a derivative, and you also need the y value. It's not an implicit derivative, it's just a regular one.
Okay, so I took the derivative, but I don't know where to go from there.
What is your derivative
Uh,
simplified?
dy dx equals. Oh shoot, I didn't simplify it. I did secant x tangent x over secant x.
Okay, what does that become?
Um, I'm not sure.
The secants cancel.
So just tangent x
Yes,
over.
yes.
Oh, just tangent x. Okay.
So then you're going to put 0 in. Tangent of 0. Got to remember what that is. It ends up being 0.
Okay.
So you get y minus y1 equals x minus x1. Do you have your y?
Uh, it's 0, right?
So it is, but let's make sure we know why. Secant of 0 is really 1 over the cosine of 0. Cosine of 0 is 1. 1 over 1 is 1. Natural log of 1 is 0.
Okay.
So it's y minus 0 equals 0 times x minus 0. It ends up being just y equals 0.
Okay.
So there's a lot of tangent line problems. It all comes down to being able to take a derivative. So quick brush up on your derivatives would probably be recommended before your next part. With the
Okay.
related rates, just make sure you always take a d variable dt with all of them.
Yep.
And you may like I mean this kind of a classic problem that they have, 50% of the time on the tests. I didn't do a very good job explaining this, so you may want to look at a YouTube video or something on this. Um, but they tend to want you to set it up like this.
Okay.
Uh, so
Yeah.
all right, we're gonna stop there for today.